Hey, what's up? Jack Davis here with DevSlopes.com, and today we're here to talk about a very popular subject over the last year or so. And that subject is protocol-oriented programming. There was a talk given at WWDC in 2015 that generated a huge amount of buzz on this subject. It continues to generate buzz to this day. Sometimes it's referred to as the Krusty Talk. I highly recommend that you watch this session if you haven't already. With the addition of protocol extensions, protocol-oriented programming has become even bigger. And in this introduction, we're going to cover a few different topics such as Swift types, the differences between object-oriented programming and protocol-oriented programming, protocols themselves, protocol extensions, and generics. Then, to wrap things up, we'll take a brief look at practical, real-world examples of how protocol-oriented programming can be used in your own projects. Now, this is just an introduction, and this is a topic that can get very complex. I hope you're as interested in it as I am, and dig in, continue learning new ways that protocol-oriented programming can help you to write better code. There's a ton of information out there about it. With that said, let's move on and get started. First, we'll quickly cover the Swift type system. So for the first part of this segment, we're going to talk about Swift types. And I'm going to pull up a whiteboard app here so I can sketch those out for you. And this is just going to be a quick run through. Hopefully you're already familiar with them. Some of the things you may not be familiar with, but we're going to go ahead and lay those out just because they may come up later on. So let's pull up a whiteboard here. All right. So we've got Swift types. And basically Swift types are broken into two categories. We have name types and we have compound types. And we're not going to talk about compound types a whole lot, but I'm going to go ahead and lay them out here just so you know how it works. And compound types, we have a group of types that are functions. And the reason I say it's a group of types is because it includes functions themselves as well as closures. And then also in compound types we have tuples. And I don't know if you're familiar with tuples or not. You may have seen them in code before. It's basically where you have two or more types enclosed in parentheses, and you can pass those around in your code. If you don't know what tuples are, I highly recommend that you look that up. Those are very handy in certain instances. So let's look at name types, and that's mainly what we're going to focus on here. And under name types we have primitives, and primitives are things like integers, doubles, strings, characters, things like that. In most languages those are all just built in to the language. In Swift they're handled a little bit differently. They're actually implemented in the standard library as structures, most of them anyway. And we'll probably take a look at that a little bit later. I just want you to understand that in Swift, the way that they create those is they take structures and they put extensions in there to give them functionality that's built into other languages. So we've got primitives. So primitive is a name type, but it's also a value type. And under value types, besides primitives, we also have structures and enums or enumerations. All right. And then also under name types, we have reference types. And it's kind of important to understand the difference because if you don't, it could cause problems. And under reference types, we have classes. And with this being a little bit more of an advanced topic, hopefully you're already familiar with object-oriented programming and classes. And a lot of times we just kind of default to using classes. But we're going to talk about object-oriented programming, obviously, and the fact that sometimes classes aren't always the best answer. Sometimes it's better to use a structure or an enum as a value type. And basically what that means is value types are passed as copies. So when you say, let me get the eraser here. So let's go ahead and clean this off here. So we're going to talk about the way objects are created. So if we have a reference type, and if you'll remember, that would be a class. And we've got a value type over here. And for this case, we're just going to say a structure. So over here we've got a class, and over here we've got a struct. Now if you create an object out of each of these things, so say we do a variable and we'll set car1 equal to an instance of a car. Okay, and then over here, say we implemented car as a struct instead of a class. So we can say var, we'll say var car1 equals car again. Now, obviously on the left side we've implemented car as a class, on the right as a struct. And then if we come on and we say var car2 equals car1, and we do the same thing on the other side, we have two different things here. On the class side or the reference side, both of these instances point to the same object. So if we did something like car2 dot color and say the default color was blue, if we do something like car2 color and we say equals red, since that's a reference and they both point to the same thing, car1 dot color is also going to be red. Now then, on the struct side, which is a value, it's passed by value. So when you make this assignment in this line right here, what that does, it doesn't copy a link or a reference to car2. It makes a copy of the actual data and passes it as a copy. So if we do the same thing over here, and we say car2.color equals red, car1.color is still going to be equal to blue. And it's kind of an important thing to understand. In most cases, we keep up with the flow in our programs and we know exactly what's going on. But if you get in a very complex hierarchy and situation, you've really got to be aware that if you set something in one part of your code, that you don't have unintended consequences in another part of your code. So that's kind of the point of this here, is just demonstrating that classes are passed by reference. So if you set something to a copy, it's not a copy, it's a reference. They both point to the same thing. Whereas a value type, it passes it as a copy. And there's places where reference types are better suited for the task, and there's other places where value types are better suited for the task. Apple always recommends going with a value type wherever possible. To quote parts of the WWDC 2015 video I spoke of earlier, structs are preferable if they're relatively small and copyable. Copying is way safer than having multiple references to the same instance, especially important when passing around a variable to many classes in a multi-threaded environment. If you can always send a copy of your variable to other places, you never have to worry about that other place changing the value of your variable underneath you. With structs, there's no need to worry about memory leaks or multiple threads racing to access a single instance of a variable. Classes can also become bloated because a class can only inherit from a single superclass. That encourages us to create huge superclasses with many different abilities that are only loosely related. Using protocols and protocol extensions allows us to eliminate the need for classes to achieve that sort of behavior. That's the official word from Apple on the subject. Structs and enums are preferred, and classes should be kind of like a fallback wherever they make sense. There are some instances where classes are going to be the only option you have. Anyway, I hope you've enjoyed this intro, and I look forward to seeing you in the next lesson. Later.